this video is to go through this week's set of notes. Remember, all the information you need is going to be on our course calendar posted on the classwork tab in your Google Classroom. Okay, so our main topic this week will be 3D shapes and surface area and volume. So let me adjust that. Okay. If you have been following along with the e-learning ever since the closures, you'll see that I've changed the course calendar a bit just to make it easier for you to read. I put the agendas and the work for when you should be working on math on the top. And then we have instructional materials here, and then remind you of when you can contact me and how you can contact me. Okay. But the notes for this week, you can find them where I put notes. And I'll be going through parts of 3D shapes, prisms versus pyramids, and then calculating surface area in general. All of these are going to be found in your interactive notebook section on Google Classroom as well. So you could either click it here or you can go on Google Classroom. So let's get started with just parts of 3D shapes. So if you see, this is a post on Google Classroom. These are the three main parts of 3D shapes. Before you could ever understand how to calculate surface area or volume, it's important that you know the different parts of 3D shapes. So we have face, edge, and vertex. And each of these words kind of build off of one another. So here you have the definition of a face. It says a flat surface of a solid figure. So they have one face shaded in gray, another one shaded in white. And ultimately, faces are just going to be 2D shapes, two-dimensional shapes that make up those flat surfaces. When we talk about edges, it's where two faces meet. So you could see the edges here highlighted in yellow. And when we talk about a vertex, or vertices is the plural, it's where two or more line segments meet. So you could have a vertex or vertices in a 2D shape, like a triangle. So it's just where two segments meet. Or you could also have them on 3D figures. And that's just like the corners of a box or corners of a tissue box and other 3D shapes. A lot of times this is also defined as where two edges meet, since edges are segments also. Okay, so this is pretty straightforward, and I hope that this isn't your first exposure to these terms. But if it is, then that's what this visual is meant for. Okay. Next, let's take a look at prisms versus pyramids. Those of you who did the e-learning within the past few weeks, this sheet is going to be a little familiar. As a 7th grader and within pre-algebra standards, it's important that you are able to get surface area of prisms or pyramids, or prisms, spheres, and cylinders. I'm including pyramids in this because I'm confident in your guys' skills, and same thing with cones as well, as you'll see later. Okay, but in addition to knowing the parts of 3D figures, you should be able to name them and tell the difference. Okay, so on this set of notes, you'll see the different characteristics of prisms, different characteristics of pyramids. For prisms, they'll have two bases, whereas pyramids only have one base. The faces of prisms are going to be parallelograms or rectangles, and for pyramids, their faces are going to be triangles. And for both of these, you name the prism or the pyramid based off of the bases. Okay, so it explains that over here, and then these are some great examples. So I'll just go over one of them in detail. So this is considered a triangular prism. And the reason why is, first off, I know it's a prism because I see that all of its faces are rectangles. And then it's a triangular prism because the two bases, I know there's two bases, so automatically that's a prism, are triangles. Here, I know this is a pyramid because there's only one base. There's only one part where it could really sit flat on. And I also know it's a pyramid because I see that the faces are triangles, and this is considered a square pyramid since its base is a square. Okay, more examples are down here. Both this set of notes and then the parts of 3D shapes these could be used to help you with the first assignment, or one of the first assignments that I assigned for the week, and that's a 3D shapes vocab practice. Okay, and then what will also help you with that vocab practice is the calculating surface area notes. If you're still confused about the notes, know that I also put 2 Khan Academy videos there for you to help you for extra support. Okay, but let's take a look at the calculating surface area notes. So in these notes, you'll see 3 pages. The first one gives you the different shapes, how to calculate the surface area, and their formulas. The second page, I'll go through prisms and pyramids, and then the third page, I'll go through spheres, cylinders, and cones. Okay, so let's focus on just calculating surface area in general. So for calculating surface area, some of the shapes you'll need to use a formula, and other ones you don't necessarily need to memorize or use a formula. You just got to use the definition of surface area. Okay, so when we talk about surface area, and I apologize for the pounding in my condo building, one of my neighbors is getting construction done, so I'll try to talk as loud as I can. But when we think about surface area, I always use the comparison of imagine wrapping a gift with wrapping paper, right? So surface area would be the amount of wrapping paper you would need. Or a lot of people also use the analogy of, oh, surface area is the amount of paint I need on a wall or amount of paint I need to cover something. So when we think of surface area, it's always the outside of a 3D shape. Okay, the ones that I'll be marking in green, so the sphere, the cylinder, the cone, and the half sphere or hemisphere, these are ones where formulas will be needed. My bad. But they're the ones where formulas are needed. Okay. The ones that I'll be marking in blue, so these 2 pyramids, this prism, and these 2 prisms. These, you just need to use a net diagram, and that'll make more sense as we go through this in a bit. Okay, so let's go through the ones where you just need to use a net, right? When we talk about net diagrams, imagine taking a box and unfolding it. The net diagram is kind of a mapping or an outline of what that 3D shape would be if you unfolded it. So here are some examples of prisms and pyramids and their net diagrams. When you calculate the surface area, all you need to do is take the area of every single shape inside and add them together. Those of you who did the composite area assignment, that's why I made you guys do the composite area assignment, because you're essentially just getting the area of a composite figure, right? I like this diagram or this chart because it explains to you for the ones that you need to use a net, you just get the surface area by adding those areas, right? So for a square base pyramid, you add the area of a square plus the area of 4 different triangles, right? For a rectangular prism or a cuboid, as it shows over there, you do twice the area of each rectangle that's present over there, and then same thing with the square base pyramid up there. Okay, so I'll go through one example of a pyramid, one example of a rectangular prism. So imagine that this is the 3D shape that they give you, right? If you're using the net, I just think, oh, if I unfold this, it'll look something similar to this. And then in this diagram, you have 3 different kind of rectangles. So I see I have a 4 by 5 over here, and that's a 4 by 5 over here. So there's 4 4 by 5 rectangles, and then there's two 5 by 5 rectangles, or squares also. So this would be 5 and 5. Okay, so that makes these 5, and then that means these are all 4. Okay. So I know that the area of this one rectangle is just going to be 4 times 5, because the area of a rectangle is length times width, and that's 20. And then the units here are centimeters squared. Okay. And then the area of this rectangle or square is going to be 5 times 5, because the area of a square is the side squared. So that's 25 centimeters squared. So that's the area of this one right here. To get the total surface area, just like you would for composites, just add all the areas together. And when you look at the formula that they you just do the length times width, length times height, width times height, and multiply that by 2. So you could use that formula, or using the net diagram, I just know that there's 4 of these rectangles that are 20 centimeters squared. So that's 80 centimeters squared. And then there's 2 of these rectangles that are 25 centimeters squared. So I just do 25 times 2, and I get 50 centimeters squared. And then, so the total surface area would be the sum of 80 and 50, and that's 130 centimeters squared. Note that because we're still talking about a type of area, your units are always going to be squared, okay? I'm not going to go through all the steps, but it's going to be a similar argument for this prism over here, right? So if I'm given this triangular prism, I see that it says that it's a 5 by 3 triangle, and then 4 is the height over here, so that's 4 and 5. This would be 4, this would be 5 over here. 7 by 5 is one of the rectangles, and a 4 by 7 is another rectangle, and a 7 by 3. So 4, so that's 4 by 7 over here, 7 by 5 over here. This one would be the 5. Four by 7, and then 5 by 7. Sorry, I mislabeled that. This is 3, this is 5, and then we have a 3 by 7, and this is 5 over here. So I know that was a little tricky. You see how I labeled the dimensions, okay? But I know that the triangle is a height of 4, because that's what it shows over here, and a base of 3. So I made sure it was height of 4, base of 3. And then there's another rectangle that's 3 by 7. So I have that here. There's a rectangle that's a 4 by 7, because that's this length. That's 4 by 7, and one last rectangle, and that's the largest one, and I'll show you that the largest one is 5 by 7. Okay, so I won't do all the steps, but you would just get the area of the 2 triangles, the rectangles, and add all of them together, just like we did with that prism. Okay, so that's prisms and pyramids overall. Same thing with the pyramids over here. So your goal is to label the dimensions on the net diagram and then add up all the areas together. For spheres, cylinders, and cones, those are the ones that I labeled in green. Formulas are definitely needed, just because sometimes it can be a little tricky to get the net diagram of a sphere, to get the net diagram of a cone, right? So I'm just going to plug them in to the formulas. Formula for the surface area of a sphere is 4 times pi times the radius. So So surface area is 4 times pi times the radius squared. And I just plug in that given information. So 4 times 3.14. Here it shows that the diameter, so the full length across, is 4. So the radius would be 2 squared. And if I just quickly plug that into my calculator, give me 1 second to do that. I just do 4 times 3.14, that's 12.56. 2 squared is 4, so 12.56 times 4 is 50.24. Okay. And then remember, this is still a type of area, so you would do the units squared. Okay. For the cone, the formula for that one is pi times the radius times the length plus pi times the radius squared. Okay, so surface area here is pi times the radius times the length plus pi r squared. Those of you who remember circles assignment, you actually are taking the area of a circle, so that makes sense. I'm taking the area of this circle and adding it to the area of that cone wrapping area. Okay, and when it talks about this L, that's the slant height, or just that lateral length. So here, this would be considered L. Okay, so we just plug it in. So 3.14 times the radius they give us is 13, slant height they give us is 29.1. And then we add that to 3.14 times 13 squared. And if you notice, I'm using 3.14 for the radius just for ease. But if you have the pi button on your calculator, you could use that too. So I'll do 3.14 times 13 times 29.1. So that's a fairly large number, but so the surface area of just that cone shape, the one that wraps around, I got to be 1,187.86. I'll just round it to the nearest hundredth. And then I add that to the area of the circle, the base. So that's 3.14 times 13 times 13, because it's 13 squared. That's 530.66. If I add these two values together, I get about 1,718.52 inches squared. Okay, so it looks like a lot, but all you're doing is plugging in values into a formula. Okay, and last but not least, let me do the surface area of a cylinder. I give you, oops, my bad. I give you that formula on the first page, remember? So let me scroll to that first page. For a cylinder, it's 2 pi r squared. So it's the area of the two circles times pi times the diameter. So that's 2 pi r squared plus pi times the diameter times the height. Let me make sure I wrote that down correctly. Yep. So in this one, since they give us the diameter, I know that my radius is half of that, so it's 10. So I'll do 2 times pi times 10 squared plus pi times the diameter, which was 20, times the height, which they give us to be 13. And then give me a few moments to plug that into my calculator. So that's 628 plus 816.4, and if we add all that together, I get 1,444.4. Okay, and then remember your units squared. When it comes to estimating these, I prefer that you guys round to the nearest hundredth if you're able. In this one, it gave you my answer in the tenths, so I'm just going to leave it in the tenths. But when it comes to the assignments related to surface area, your Khan Academy practice, please just make sure to read the directions. Okay, so read the directions on the question. Is it asking you to round to the nearest whole, tenth, or the hundredths? Okay, so I hope you guys have better insight on how to calculate surface area. If you have any further questions about this, please feel free to shoot me an email. And I hope you guys stay healthy and are taking care. Thanks.